Hello, my name is Luis Perez, and I'm a second-year graduate student in mathematics and hope to complete my degree this semester. I'm a first-generation college student and an underrepresented minority in mathematics. My academic and career goal is to earn a PhD in mathematics and become a professor that teaches, conducts research, and most importantly, takes an active role in diversifying mathematics. I have been accepted to a few PhD programs, and I'm currently in the process of deciding where I want to go. My math research lies in the area of combinatorics and discrete geometry, where I'm currently working under the guidance of Dr. Federico Ardila and Dr. Matthias Beck. My main research problem concerns an important tool called the cosine partition function. The cosine partition function of a finite root system a(n minus 1 counts the number of ways of writing a vector as a linear combination of the positive roots of a(n minus 1. The image on the right is a two-dimensional slice of the regions of the cosine partition function in the case of the root system A3, which lives in four-dimensional space. Notice that there are 7 regions labeled from 1 to 7. The cosine partition function is used to understand the representation theory of semi-simple Lie algebras. The Lie algebras and the representations are used extensively in physics. My main research problem is the following. Why is it that for many regions of the cosine partition function for the root system a(n minus 1, its corresponding polynomial has many linear factors? It turns out that we can enlarge each region, as there are vectors in the large regions that also satisfy the respective polynomial for the cosine partition function. These enlarged regions predict linear factors. It turns out that we can define a unique polynomial function in each region that describes the cosine partition function of a vector that lives in a respective region. Going back to our example of the root system A3, the polynomial functions are given on the left, and they are labeled based on the region they correspond to. Notice that the polynomial functions of regions 1, 2, 4, 6, and 7 contain nice linear factors, and equations 3 and 4 are a difference of polynomial functions that contain nice linear factors. The image is a sketch of the enlarged regions for the cosine vector partition function of the root system A3. The pattern that we discovered is that the linear factors that appear are exactly the expressions of the equations that define the outer walls, which are represented by the bold lines in blue, black, and gray. This completes a short summary of my research. Thank you.